Hi everyone. Hi everyone. That's better. I'm Konstantin. You can find me on social networks as Everzet. I'm generally a part of BDD community, and I'm the guy that created de facto standard BDD tools for PHP. I also am hosting London BDD Meetup, which is a great pub event every 2 months where we have amazing people like Dan North, Liskio, Matt Wynn, Aslak, and hopefully at some point Seb, talking about general agile communication and software design. So if you're nearby London at the dates where we have a meetup, please join us. It's an amazing free event. There's a lot of people joining us there. Come and share. You can find it at meetup.com. Just search for London BDD. I'm also working at the company called Inviqa as a BDD practice manager, which basically helps me to make sure that our teams delivering software that matters through agile communication and collaboration. But back to this talk. This talk is Taking Back BDD. And basically it comes from this idea of, if you go back to the behavior driven development, it started on 2 very simple pillars or premises. It's software design in the core and communication, right? And some might say that communication is the more important aspect of it. I think they both are equally as important. And then over the years, it kind of derailed, and people started believing that TDD or BDD is more about testing than it is about either of those two, communication or design. And over the course of last couple of years, we started kind of pushing it back on rails in terms of like, this is actually a communication practice, a communication technique. What we did forget about is that it also is a very interesting and expressive design technique, and that's something that I want to talk about today. So I want to take BDD back where it started and talk about it. BDD as a design technique, how you can use agile communication to drive design of your software. So behavior-driven development, well, what is it? Behavior-driven development, in a very simple terms, is when you take a user story like this, in order to spend more time socializing and less time choosing talks, or tracks, as a conference attendee, I would love to arrange my personal schedule beforehand, right? Simple user story, somewhere along the lines of the Wova app if you're using it for Agile on the beach. So the first thing you do is you're having a conversation with your stakeholders or your product owner, and the first thing you ask is, can you give me an example, right? And through the set of these conversations where you're like asking back and forth and talking in examples, you end up with something like this, right? You end up with some form of examples written down or spoken about that illustrate how the system should behave. So this is a good example in declarative style. So given that there's a conference Agile on the beach and there is a Taking Back BDD talk in the first time period, when I choose Taking Back BDD talk, then the Taking Back BDD talk should be in my personal schedule. Right? And then we have a negative where like we're trying to choose 2 talks in the same time period and it just doesn't work. Now this is where most BDD practitioners would stop, right? This is a good enough example. We can drive implementation with this. Over a year ago, I started thinking, what if we start pushing it a bit further, right? What if we don't stop here? What if we don't stop our conversation here and we actually start questioning things inside this example, right? What if we look at this very critically and we ask our product owner or stakeholders, so you're saying there is a conference Agile on the beach. So this Agile on the beach title or whatever it is, how is it connected to the conference? What's the connection between this like string, text, and conference? Also, you're mentioning this time period. What is a time period? Can you give me an example of time period? Like, how does it, like, what is it, how do you call it when you're organizing conferences, right? You choose the talk. You choose a talk where? How do you choose the talk? And you have this very deliberate discussion with your product owner or stakeholders. No technical knowledge required, but you're trying to understand and extract as much knowledge about their domain, about their business as possible. Actual terms they use, actual terminology they go with. So you start with this example, or with this scenario, and you start asking, how do you actually call that thing? And one of the possible outcomes is you would end up with more expressive scenarios like that. Given a conference named Agile on the Beach 2015 with 1 track, So now we know that this text is actually a name of the conference, and that's how it related. We also know that the conference have a number of tracks. As you can see in the first scenario, it's 1 track, in the second scenario, it's 2 tracks. We also see that a talk is scheduled for a particular slot. It's not time period, it's a time slot. And a time slot is a period of time, range of time, from 16:30 to 5 p.m., right? That's a slot. We also see that the talk has a direct relationship with a time slot and a track. And we choose the talks for our personal schedule of this particular conference. And we extract all those connections and information and terminology just by talking with business, just by talking with people that do understand how organization of the conferences and general attendance of the conferences work. So what we're doing is we're basically adding ubiquitous language to our examples. You might ask, why is it important? Well, I can quote Eric Evans from the Blue Book, or the Domain Driven Design book. A project faces serious problems when its language is fractured. Domain experts use their jargon, while technical teams members have their own. Just to illustrate it very simply, on the very, very simple scale, the way I see the software development from the human perspective, it goes like this. We have somebody, some person that wants to develop software, some business guy. And he comes up with some very interesting feature, or even better, a need that he needs software to fulfill for him. He communicates this need to somebody with a technical mind. And that technical mind immediately transforms this need into a set of instructions or abstractions on technology need choices, which then gets passed by to another system, which is computer, right? And computer also transforms it into a set of bips and bobs that then gets fed back to the customer in a form of ready system. Now, this process might have taken us like a year or months in best case scenarios before Agile, and we kind of optimized it. We say, okay, now we can get it for a week, right? Very short terms, or even in best cases like a day. But the problem is, if you have misunderstanding between these two first guys, if whenever business says like, I want accounts, meaning credit accounts or debit accounts, and then technical guy listens and hears like user accounts, thinking about user registration, password recovery, all these things, this misunderstanding isn't cleared up until you deliver something after this 2 weeks. And delivering something wrong, completely wrong, after 2 weeks is still a problem, right? Yes, it took you just 2 weeks, not a year, but you still delivered something that business didn't need, and you still didn't deliver something that business really, really needed. So this problem, when two people talk in the same language, use the same terminology, but imply different meaning, is called translation cost, right? There is a translation involved. So one person heard one thing, but implied another meaning. The way we solve translation cost, and that's a common thing that we were like banging on for the last almost 10 years, we solve this with practices like behavior driven development. So the way we solve this is we introduce this feedback loop. Whenever your business says, I want accounts, the first thing you do is not go and try to implement it or plan it. The first thing you do is you ask, can you give me an example of how this account will work? How would you use it? And then they give an example, and you immediately, as an engineer, understand, oh, it has nothing to do with password recovery. He actually talks about credit accounts, right? And that feedback hopefully eliminates the cost of translation. But in order to do this, you need both sides to talk in the same language, right? You can't throw back and forth examples in both technical and business language. You need both sides to use the same language. Obviously, business is not very good at talking in technical language, so developers need to step up and start talking in the terminology that business understands. Usually it's business language, so that's how we usually do BDD. And hopefully, business is happy because you keep delivering the thing exactly what it needs, and you keep doing that on a continuous basis, right? And you're also happy as an engineer because business have a need, and it takes you just a day to put this need into the code base, like integrate it into your code, into your design. But then something starts happening. Over a course of a couple of iterations, maybe like a month or 2 or 3, you find that something that would have taken you days to integrate into your software now takes weeks. And that makes you unhappy, right? And the reason why it makes you unhappy is that even though you, as an engineer or the team, talk in the same language as business does, whenever this conversation stops and you go and start writing these instructions or writing this logic into the program, this program has no relation with the business whatsoever. You just write a set of instructions that are not connected with the business rules you just discussed. So you still have translation cost. It's just translation cost, not between the team and the business, it's between the business and the code that you wrote. And whenever business needs to change, that change is a completely different thing altogether to the code base you end up having. And those two things, as time goes on, become more and more separate and more incompatible. But we know about this problem because that's the kind of problem domain-driven design is supposed to fix. And how is domain-driven design supposed to fix this? Well, we introduce a feedback loop. So whenever you're coming up with design or a model to structure and abstract your code, you're verifying it with the clients, right? You're going back to your customers and you're saying, okay, so it's like, here's how I understand this. Here's how we will implement these business rules on the very, very high level without going into code details. And business says, yes, that makes sense from the business perspective. Of no, that rule you're talking about doesn't make sense for me. You're actually breaking the rules of like how this business works. And again, in order to do this, you need now 3 parties to talk in the same language, and that language cannot anymore be just the business language because you have computer involved, and those guys are not very good in talking in pure business language. So what you need a combination of both technical and non-technical language, something that domain-driven design calls ubiquitous language. It's a language shared across business and technology. So a good example of ubiquitous language or a need for ubiquitous language would be if your business uses some terminology like credit cards, you want to represent it in the code as is. But then if you have a very limited technology or language that you're dealing with, and it already have credit card as reserved keyword, what you need to come up with another name, but you need to agree with the business that that is a better name, and that's a name that everybody will use. Otherwise, you still get into this trouble with translation cost. So ubiquitous language is the language that everybody uses, including computers, business, and technology, to talk about the problems you're trying to solve for the business. Now, hopefully that solves a problem, and now introducing the changes that business needs on the ongoing basis, again, takes hours, not days, not even weeks. And the only problem that remains is that now you have everybody happy there, but the practices you need to involve, domain-driven design and behavior-driven development, take incredible amount of effort and time to implement. It took me more than 4 years to learn and understand deeply what BDD means and how it should work. And it took me more than 2 years to grasp the basic concept of domain-driven design, and I'm still learning. And now I'm kind of telling you, just like you need to operate with both in order to eliminate this translation cost at 2 different levels. Because they are very different practices, right? They have very different set of tools. They're very incompatible. At least that's how we see them. So let's look at tools. So what are the most famous or the core tools of both domain-driven design and BDD? Well, BDD, famously, the most famous and maybe the only tool that BDD needs is examples. So example is that, right? So that's a conference example we talked about before. Now, domain-driven design uses a different thing, which is domain models. So domain model is a representation of the business rules that you're looking at that you need to implement in the code base. It's a small fraction of the business represented in form of some sort of abstraction. Now, the way we're looking at or thinking about domain models usually is like it's a set of diagrams or a doodle on the board. The way Eric Evans describes domain models in the book is that it could be anything, actually. It could be a word, it could be a sentence, it could be a paragraph of text describing things. A sentence can be a domain model, one of the domain models you have, right? The only requirement is this domain model, this sentence should represent and use ubiquitous language. So in this regard, if we look back at our example with ubiquitous language, that can be treated as domain model. So the premise of this talk is that pushing for ubiquitous language in your examples makes them a domain model that you can use to drive not only implementation of your business needs, but design of your underlying software, which allows you to do a very interesting thing. It allows you to take your scenarios or examples or Gherkin features and use the same feature to drive both the domain model and the UI of your software. And this is a process that I call modeling by example. So you model your software by example. Similar as specification by example, you specify what the software needs to do by example. Dan North calls it BDD as it was meant to be done. Had a discussion with Dan, and he said it's like, that's how I envisioned BDD in the first place. So in order to combine both domain-driven design and behavior-driven development, you need to look at how both of them go, generally, right? And to simplify the general design at higher level, here's how any application looks. You have a user interface at top. Underneath that, you have application services that represent higher level abstractions. And then at the very bottom, you have domain objects that represent some small level business rules in your system, right? Rule objects. So your user interface interacts with application services that then delegate pieces of work across domain objects. So the common way to do behavior-driven development is called outside in, because you go through the user interface, touching all the layers down the road, right? Because in behavior-driven development, you care about the entire application, right? Does it fulfills the need of the business? Now, this approach creates a problem for domain-driven design, because in domain-driven design, the only two layers that you care most about are the green one and the blue one, application services and domain objects, right? And if you're going outside in, you're kind of hiding those very important layers behind the UI. So that's why in domain-driven design, the most common way to do DDD is middle out. So you start and you implement application services, and then you implement domain objects, and then when you're done, when the logic works and tests pass, then you move on and you build infrastructure and UI on top of that. So modeling by example is a combination of both. It's a practice that basically takes those two very separate ways to design software and tries to mold them into one practice. So as I said, the most important bit for DDD is modeling the domain right, this inner piece of your software. So that's why the first step in modeling by example is to take UI out of equation and basically implement the domain logic, the business logic first. Separate it from UI, separate it from infrastructure, separate it from persistence layer. And I call this step abstract because you're creating abstractions for the real business rules that you have. And when you're done with that, you add UI back and you go through the second step, which is, again, outside in, but now you're going through UI. You add UI into the mix. All right? I know it's kind of cryptic, but that's why for the rest of the talk, I will just show you one particular example of how I would go and implement that particular feature that I showed you at the beginning in modeling by example way. So we will go about seeing example of modeling by example. So again, just to not make things harder, we will use exactly the same feature. And again, the first step, phase one, we abstract it, right? We implement business logic separately from UI. And again, as with anything TDD, we go step by step, scenario by scenario. So we start from the very simple case, straightforward use case, right? And we go step by step through it. Now, for the rest of the talk, I will show you code, but the code will be in PHP as a language. There's two reasons for that. First of all, PHP is my native language. I do write in different languages, but PHP is more comfortable. The second reason is PHP is fairly known as clumsy language in terms of its syntax and very, very expressive nature. And I want to show you that that sometimes is not a downfall, not a problem, but it sometimes plays in your favor if what you're trying to do is represent your business as close as possible, or like use the clumsiness of the language, if you wish, in your favor when you're modeling the concepts from the business. So the way BDD practitioners go about this and using like tools like Cucumber or Behat in PHP is you take your steps and you implement the underlying code, like test for this step in the matching algorithm, right? So you have this context object which holds all the step definitions. Step definitions represent the logic that you need to call whenever this step is executed. And at the moment, there is nothing there, and we need to fill it with particular test, right? And if we're going outside in, that would have been probably UI, but now we're decided deliberately to not go through UI, we're going through the main. So what we need to do here is to design things. We need to create objects, create methods, connect these objects, connect these methods. And it's like, this is deliberate work that you would usually use like charts for, or like talk next to the drawing board with your teammates. But for the purpose of this talk, I would ask you to step back from this process and imagine, just for 40 minutes, what if you wouldn't do all of this? And what if you will try to extract all this information, all those design decisions, from the actual conversation you just had with your stakeholder, with your business? What if what we would try to do is to transform this interaction, this communication that you had with the business, into the code, as close as possible, eliminating all the possibility of translation cost? So how might it look like? It might look like this. You start with a sentence above, given a conference named name with count tracks. So the first thing you have there is a conference, which becomes a conference variable. So what do you assign to the conference variable? Well, a conference is a conference named with tracks, which becomes conference object with a static meta factory named with tracks, and you pass name and count. Right? And look how close it represents the sentence above. And suddenly, without actually thinking about objects, without thinking about naming, you already have one object and one meta net. And the first thing that people ask me when I show this in the workshops or in the trainings or at the conferences is that we usually do this as a design activity. We usually have somebody that represents a lead designership role, and he designs like a system how it should be, or maybe like we all represent designers. Where did design came from here? And the answer is design came from the conversation. And I see very interesting patterns there. Depending on how your business describes problems, depending on which language it uses, you will end up with completely different designs. So in our case, business said, given a conference named with one track, which led us to create one object conference with one method named with tracks. Now, if instead of that, business would have said, given a conference named, and this conference is planned to have one track, we would have ended with a slightly different design. We would have a conference as a separate object with named methods, and then we would have had track planner, a separate object that is responsible for planning tracks. We're moving on to the second step, and the Taken Back BDD talk is scheduled for a particular slot on the track one. Again, the same situation, right? We need to transform this sentence from above as close as possible into the code. So talk is scheduled becomes schedule talk, right? Where do we schedule talk on? Well, we schedule it on the conference, right? So this conference schedule talk, and we pass talk, slot, and track. And suddenly we have 3 more objects and relationship between them and the conference. And this is the point where some people start asking, is how did we end up with this? It's like now you start having relationship, now you start, abstractions start to emerge. And the answer is, the reason why this works, the reason, the explanation of how it works is the thing called natural abstractions. So we're all aware of this thing called artificial abstractions. So whenever we have two pieces of logic and they share a lot of behavior or a lot of properties, what you do is you introduce artificial abstraction that is shared across them to maybe a parent class or maybe an interface in the best case scenario, and then you implement it with 2 different classes. The interesting thing is we kind of do similar thing with language for thousands of years. So there is a complex concept in our day-to-day lives, like when people ask did you eat? And I would answer, well, yes, I had eggs, and I had beans, and I had sausages, and all this was well cooked and stuff, right? Repeating the same answer, very long sentence or a paragraph of text, every single morning to every single person is not very efficient. So what people do, they come up with a word that describes this paragraph of text, like a breakfast. And the interesting thing is we're very good at abstracting complex concepts that take more than one sentence to describe in one couple of words. Where do you think credit counts came from? Where do you think debit cards or debit accounts came from? So that's us as human beings trying to replace something that took a paragraph of text to describe with 1-2 words. And the cool thing about natural abstractions is that they tend to live longer, 10-folds more longer than artificial abstractions. Artificial abstractions you tend to replace, rewrite, change every 2-3 months on the project. Natural abstractions are very hard to replace because it's human language. Whenever you start calling something debit account and everybody in the company used to it, it's very hard to start calling it something else. So locking your code to natural abstractions over artificial ones is genuinely a better idea. When I choose the Taking Back BDD talk for my personal schedule of this conference, again, the same process. I choose the talk, becomes choose talk, and you pass the talk. Where do you choose the talk for? Well, you choose it for my personal schedule. So my schedule, choose talk. What is my schedule? Well, my schedule is a personal schedule of this conference. And this is an example of which one, the one I was talking about. This is where the clumsiness of the language kind of plays in. It actually represents the sentence closer, right? This conference. So this schedule equals personal schedule of the conference, this conference, and I choose the talk on this conference, on this schedule, sorry. So now you have another object that is also connected with talk, right? And this is the point where most people start asking, what if we get it wrong? I see the pattern here. You're creating a code based purely on the conversation you had with the business. What if business forgot to mention something? Or what if business used the wrong words? And the answer here is, it's totally fine to get it wrong, as long as you're okay to improve it on the ongoing basis. So the way it works is you have a conversation, you learn something about the business, you learn new terminology, you obviously will miss some things, but then you will put it into the code and you will see that some things just don't fit from the logical perspective. And that will enrich your understanding, and you will find that there's some blind spots there. You will go back to your business and you will start having a conversation. That thing, how do you call that thing that we didn't talk about? Oh, you call it this. All right. And then you go back and you update your both scenarios and the code. So those two things start co-evolving together, your conversations, your understanding, and your code. Then the talk chosen for a particular slot of my schedule should be the Taken Back BDD, right? Again, the talk chosen for slot should be, we assert equality here. And that did not require us to create any new objects, but it did require us to create talk chosen for slot method on the personal schedule. And this is the point where you will have your first actually failing step in the scenario. Like, it will be actually red because talk is not chosen. And this is where you will start implementing it, and then you will see that there is a problem. And the problem is there is a personal schedule, which is connected to talk. And then there's a conference, which is connected to 3 things at the same time: track, slot, and talk. So conference treats those 3 things as the same object or as the same concept. But we never talked with business about this, right? It's like track, slot, and talk, the only thing that we mentioned. So there is something missing. There is some underlying principle that is never mentioned in the conversation, but it is there. So what you do, you go back to your business or your stakeholder or somebody that understands business, and you ask him, so it seems you use track, slot, and talk together for a particular conference. So how do you call those 3 things when they are together? And the business will say, well, we call them scheduled talk, right? It's a talk scheduled for a particular conference. And by implementing this through unit tests, obviously, which is a different kind of test, you will make the step green. And this concept of driving external behavior and then pushing implementation of internal behavior at the same time, or using acceptance tests and unit tests together, kind of reminds me the whole concept of growing object-oriented software, but I think it pushes it a bit further. And I showed it to Nat Price, and he loved it, but here's the concept. It's planting object-oriented software, not just growing it. So the concept, imagine your software is your goal is to grow a tree, which is a software. So you plant a stick into the ground, and then you hope that someday this stick will grow into the big tree. In order for this stick to grow into even moderate-sized tree, it needs to have a lot of roots underneath to support it. Otherwise, it will just fall back. Right, so those roots are your underlying small business objects that implement particular small pieces of business logic. The tree itself is your external behavior of application, is your application as users, business people use it. The ground, if you wish, is your unit tests. They put a pressure on your small domain objects to make sure that they work properly. Your roots are there, and they support your tree. and the air around your trees put a pressure on the tree itself, which is your acceptance test. They make sure that all those roots are doing the job that does add value to the business. But generally, you end up with scenarios that are green. And in our case, our first scenario is green. We've done our job. Our business logic works for this particular use case. And this is a time to switch to another one. I would skip all the process, but basically it's enough to say that as part of this process, you would need to introduce slot is already taken exception that personal schedule throws if you try to put 2 tracks from the same time slot into your personal schedule. And you get your green scenario. Actually, both of them are green. Now, the key there is we implemented business logic, we implemented business rules, we implemented guards in place, but there's no UI. Business cannot literally use it. Business can trust you that it implemented properly. Business can look at the scenarios and the examples and say, yes, that sounds like exactly like I would use it, but business cannot just go into the code base and start using your API because business doesn't know tech. So in this regard, why do we do this? And there is a very simple answer that I give: shorter stakeholder feedback loops. So the way we do outside in development, or the classical BDD, is we implement the whole thing altogether. And for a very simple feature, for a very simple scenario, it means we need to implement domain, persistence layer, and UI all together, which could take days or weeks. And it's days or weeks until you get to the actual domain and you find out that the logic, the conversation you had is completely incompatible. You were going for those 3 days or a week in a completely wrong direction. And this is where, like, after 3 days, you go back to your business and say, look, didn't work. We missed something. Oh yeah, you missed this very core concept. Eliminating persistence in UI allows you to shorten this feedback loop, shorten the feedback loop purely around your business logic to hours. So you can actually talk with the business, put the business logic in the code through test-driven development, see if it works, if it fits, if it aligns with the design, and then if it doesn't, after a couple of hours, feed it back to the business and get your design aligned with it, right? And then when you're done, then when everything is working, then you move to the interaction phase. Then you say, okay, I know business is happy about how his rules are implemented in this particular code base. Let's add interaction on top. And as I said, it is important to state that just having business logic without UI, you cannot deliver it to the customers. It's not value. They cannot use it. But that said, when you do have your scenarios or your tests running, that represents clear conversation with the business running against your domain, and all of them are green, representing that your business logic works exactly like business expects, you do start looking at the UI in a very different fashion. UI stops being this like overlying layer at top of your application, something that you absolutely need to do or need to have in order for this application to be there. It stops being this layer and starts being more like this. It starts being a controller that you plug into your application services layer, right? Just to give your application input and get an output out of it. And the cool thing about this is, like, then you start thinking, okay, so then I could have different controllers, right? I could have one joystick that will represent HTML or the browser, and then another one which will represent mobile application or even API. So going back to the interact phase, you take this feature, and now reusing your domain model, you go again through this feature, implementing it, but now using UI, going through UI. And this is the point where people ask, do we literally need to drive every single scenario through UI again? And it's basically what it means is, you have your abstract phase where you implemented 6 scenarios, right? They're all green. And now we need to go through interact phase and implement all 6 scenarios through UI again. Is it? And the key there is this rule of diminished returns for the UI tests. If you have proven that your business logic works internally and it covers you against malicious or bad edge cases, you don't really need to cover this edge case, like a lot of these edge cases in the UI, right? So there is this diminished return in the UI. So there will be some edge cases that you want to provide feedback to your customer, to your stakeholder, whenever he enters something wrong. But there will be edge cases where nobody will actually enter this data unless he has bad intentions. And do you want to provide clear feedback to this guy? Well, no. Just 500 it. Just give an exception. Website will stop at this particular page, and that's as far as he will go. He will have 500 page. He wouldn't have any clear exception, but your business will protect you against this malicious intent. Which means you don't really need to go through every single scenario. Just a couple of them, the critical ones, the ones that cover the most important cases. And the way you do this is you go through your feature and you tag scenarios that are critical with a critical tag, and you implement only this. So again, now we will use different step definitions. We will implement this thing through UI. For given steps, it doesn't matter how you get the initial context into the system in your tests. So you can reuse your domain step definitions. So the same steps, you just copy paste them. Now for the when though, this is where you actually start going through UI. Whens and thens, you make actions through UI, represent an actual user doing actions through UI. And then you do assertions or then steps also through UI, making sure that the user actually gets the feedback. So when I choose the taken back BDD talk, and this is where we're actually going through UI. So we visit some page, in our case it's the conferences page. We add the conference name at the end. Then we find particular CSS or div block on the page that contains the name of the talk we're interested in, and we click add to my schedule inside this guy, right? And then you will start writing your HTTP wiring, maybe use a framework. You will start running your application through HTTP, and you will very soon run into this problem where you cannot add anything to your schedule because the talks aren't actually on the page. Because the step that you used before, where you said conference named with tracks, and then you added talks to this conference, it's not there, right? Because when you are going through the web server, it's a very different process to the one you run and test with. So there is a persistence problem. So whenever you're creating this conference, you need to persist it somehow now. And it wasn't being there. Our domain logic didn't require persistence, hence it wasn't in there. The natural answer from people that were just exposed to DDD, domain driven design, is to slap a repository on it, right? So it's like, we need to store conferences, so let's create conference repository and save a conference inside the repository. And that's the way where you're like assuming that everything was right with your conversation with the business, everything was right with how you translated it into the code. The actual thing that is wrong is just like, well, we just need persistence. It's just the code that we've written in the first place is wrong. But what if I tell you that there is another way? You can step back and say, what if it's an actual conversation that we had with the business that was missing something? And you go back to the business and you say, okay, you're saying, given the conference named with tracks, do you keep a track record of the conferences? How do you know that there are conferences? If you organize 100 conferences, do you just remember them? Like, where do you store them? And the business might say, well, we planned them, right? So given the conference named with number of tracks was planned. Oh, okay. So we need a conference planner. And we put conferences into this planner. And that's our persistence layer. So this creates this very interesting, as I showed before, scenario where your domain and scenarios, your conversations are evolving together or co-evolving. Your scenarios drive your domain code, and then domain code, when it doesn't work anymore for tests, drives you to have more scenarios or more discussions with the business, and you update both at the same time. So that's what living documentation means. Living documentation doesn't mean that you're like, you write documentation once, and then it fails every time that you're like breaking it. Living documentation means documentation living together with your code. Then the talk chosen for a particular slot of my schedule should be and we basically do a web assertion. So we assert that the particular element exists on the web page, right? In this case, there is a talk in my schedule that has particular time slot and the name. The interesting thing happens here when I'm giving like a workshop, so like a practice sessions to guys. And it's, they implement things in a very different way and they find out some interesting aspects of how they approach general programming problems usually. One of the teams I worked with, we were going with very simplistic example of like implementing a basket calculation. Basket was calculating VAT inside it. And one of the guys implemented domain without problem. But then when they got to this infrastructure problem, there was missing persistence layer. Everybody else implemented persistence layer as a separate activity, but he went and used active record. So he basically made basket itself responsible for saving itself. And the wonderful thing happened. Then he runs both his feature against the domain and the same feature against the UI. And his feature against the UI suddenly starts working because persistence is there. But his feature against domain, which was working for the last half of day, is broken. Right? Because basket suddenly starts being persisted, and the scenario didn't expect it to be persisted. So this is what I call infrastructure leakage. Your infrastructure concerns or UI concerns leaked back into your domain and damaged your business logic. And you wouldn't see this otherwise if you're just going outside in, but just because you're running your feature and you're making sure that the business rules work separately from UI, and then you also make sure that the business logic works in the context of UI, you do see these problems happening, and you do see these problems highlighted by your test suite. But generally, this is how you get to your green scenario. And this is a very interesting state, because what you have now is you have one scenario running against your UI. You have two of these scenarios running against your acceptance or application service layer. They don't touch any UI, they don't touch any infrastructure, so they're very fast. And then you also have a bunch of unit tests supporting underlying objects, actually like implementing the logic around those, like personal schedule, conference, and all these guys. So what you have actually is you have one interaction test, or a limited number of interaction tests, a big number, relatively big number for abstraction tests, one per use case, and then you have 7 unit tests, right? Unit tests are very fast. They test objects in isolation from each other. Abstraction tests are relatively fast. They don't isolate objects, but they never talk with infrastructure. They never talk with UI. And then you have very slow smoke tests that do go through UI, but there's a very limited number of them because, again, remember, diminished returns. So what you end up with is you end up with this testing pyramid without the clear intention of ending up with testing pyramid. It's just like the process led you there. So David West has this very brilliant quote that I keep reiterating again and again. Model the problem domain and the solution will take care of itself. What I'm trying to explore here is kind of a way to expand upon this and say, what if we can discuss the problem domain and hope that the model will take care of itself as part of just discussing. Thank you very much.